says use the integral test. So let's start. So 1 to infinity, and change it to x's. That's a necessary step. X cubed dx. Okay, so limit as t goes to infinity. And let me start the process of rewriting it. E to the negative x cubed, 1 to t. You can see it, right? Let the u equal negative x cubed. Du is negative 3x squared. So I would get a limit as t goes to infinity, a negative 1/3 e to the u du. Okay, let's take the antiderivative. You know, integral d of u is e to the u. So I get 1/3 e to the u. U is negative x cubed, and I would still have from 1 to t. So take time on this. I would suggest taking the time to put that negative exponent in the denominator. So limit as t goes to infinity, negative 1/3, 1 over e to the x cubed, 1 to t. All right, let's now do it. Negative 1/3, 1 over e to the t cubed, subtract a negative 1/3, 1 over e. The x is to the third power. Let's plug in infinity. That gives me 0, so I get 1 over 3e. That means that the integral converges, right? And that means therefore this sum converges by integral test. But it doesn't add up to this, right? We just can conclude that this converges. All right, so here we have a telescoping sum. You know it's not geometric because it's not to the nth power. And so I'm going to be awarding points on quizzes and tests for you to write all the details out, and that means write out what the S sub n is. So first off, when you see a telescoping sum, you have to start off by doing partial fractions. N plus 1, n plus 2, so you know that's a over n plus 1 plus b over n plus 2. So again, you multiply both sides by this denominator. So I get 3 equals a times n plus 2 plus b times n plus 1. And this is where you know you choose wise numbers. So if I choose negative 1, I get 3 is equal to a, right? Negative 1 plus 2 is a 1, so 3 is a, all right? So what happens if I choose let n equal negative 2, right? N equal negative 2, that's 0. So I get 3 is equal to negative b. So there it is. Okay, so then what we're going to do is we're going to put them back into here. So summation 3 over n plus 1 minus 3 over n plus 2. Okay, so what can be helpful is to pull the 3 on the outside. Don't have to do this, but it can be helpful to have less numbers to deal with. Whoops, I wrote that down wrong. N plus 1, n plus 2. Okay, so then after this, do not split it up into two separate sums. So I'm going to say, what is the nth partial sum? So just so I don't forget it, I'm going to put the 3 here. And then when I plug in n equal 1, I get 1/2 minus 1/3. So that's n equal 1. I'm going to use different colors here just to make sure you see what I'm doing. Plus. Now I'm going to plug in n equal 2. So I get 1/3 minus 1/4. Okay. Plus, I'm going to plug in n equal 3, 1/4 minus 1/5, dot, 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 dot. Well, maybe I'll do another 1 just to make sure you really see the pattern. Okay, so plus n equal 4, somewhere in here, n equal 4, I get 1 over 5 minus 1 over 6. And then you have to be able to do the dot, dot, dots, right? So the last term will be n, right? last term will be, I've got that 3 on the outside, right? It'll be 1 over n plus 1 minus 1 over n plus 2. There. Okay, so then if I go to the one term before that, that would be like the n minus 1 term. So n minus 1 would be 1 over n minus 1 over n plus 1. And that'd be a plus, right? So let's investigate the canceling. This does not go away. This goes away, right? 1/3, go away. Negative 1/4, 1/4. Top, negative 1/5, 1/5, right? So you see the canceling pattern. So this will go with this. This one here will go with this. Oh my goodness, you can even see this one, right? Goes away with this. So what's left for the nth partial sum? So I've got this 3 on the outside. I've got the number 1/2. Everything cancels except this negative 1 over n plus 2. So that's my nth partial sum. So the sum, the infinite sum, is the limit as n goes to infinity of the s sub n. That's 3/2.